This video will demonstrate how the standard template library array uses templates. Hello, I'm James Helfrich. The standard template library array uses two different types of templates, a value template and a type template. This video will explain how both of those work, as well as give an overview and a review of how templates are implemented in C++. We'll start with function templates. A function template creates multiple versions of a given function. In this case, my function display has one template variable t. When I compile the code, the compiler takes that display function and turns it into two. It'll first take display and make the string version of it, and then it'll take display and make the double version of it. Now we're going to have two compiled functions when only one was written by the client. Class templates work the same way. In this case, I'm going to have one class called store, which has a single template variable t. Now, when I compile this, store is going to turn into store double because it's going to be a double version of it. And then store will turn into store string, which will be the string version of it. Notice how in both store double and store string, I have 1, 2, 3 different locations where the template variable t is used. One is a parameter to my constructor, one is a return value to my getter, and one is a data type of my attribute. In these cases, all instances of t will get turned into what was specified in the chevrons, double or string in these cases. A template variable can represent a type or a value. So the default way to do this is represent a type, and this is where we say template class t or type name t. And in either case, I can substitute a built-in data type like a float, a double, or an int, or a class that I define myself as my template variable t. And so in this case, I have my type template, and my data type of my attribute lowercase t is the template variable t. And so when I run the code, then TT will be of type string. And so it's going to return the default value of string, which is the empty string. Now, a value template allows the client to specify a constant value that is used by the client. The template must specify the data type of the expected type. So in this case, I have my value template would have an int n, not class n or type name n, but rather I'm specifying this is going to be an integer, and I expect the client to give me the value for n. And so when I say get, I'm going to return whatever value was specified in that template variable. So in this case, I'll say value template of 10. So now n equals 10, and all instances of n in the compiled template will be replaced with the value 10. The standard template library array utilizes two template variables, type and value. The type specifies the base type of the array, and the value specifies the number of elements. So if I say std : array, I must specify the two template variables. Double is going to be a type template parameter specifying the data type of the base type, and 100 is going to be the integer value template specifying the number of elements. So the declaration of the array requires these two template parameters. I'm going to have t, which is going to be my type template, and then I'm going to have n, which is going to be my value template. Notice my private member variable elms has a base type of t, which of course is a data type. And then how many is there going to be? N, which is my integer template value.